All right, hello everyone, welcome back to another video. Today I'm going to be reviewing some parallels between R3's Corda DLT development platform and Coreum's Layer 1 blockchain. In this explanation, I'm simply documenting and sharing my journey with learning about these concepts and technology. I'm not a blockchain expert or attempting to make any claims, simply just asking questions to satisfy my curiosity, and of course, none of this is financial advice. Also in this video, I'll assume you have a basic working understanding of Corda and Coreum, and if you want to learn more about these technologies, I'd invite you to watch some of my previous videos or somebody else's videos on these subjects. There's plenty of good information and videos out there. Also, shout out to Skills for this awesome graphic. So I want to just start off with a basic understanding of a permissioned versus a permissionless network. And in my understanding, Corda is a blockchain framework with no native token and is permissioned. And then Coreum is a blockchain with a native asset core, and in my understanding is a public, aka permissionless network.
And today we're going to continue our blockchain discussion with permissionless versus permissioned. Generally, the answer to which blockchain is best would be completely subjective. But here at Akeo Tech, we're not talking about things in general terms, we are talking about things in business terms. So I think today we'll be able to be a little bit objective about how we attack this question. Let's begin with the first of the two, permissionless, also known as public or decentralized blockchains. As we go over the characteristics, I want you to consider if these would be pros or cons according to your business model. Okay, so permissionless blockchains, anyone can access and create data. Anyone can create and publish smart contracts. Anyone can run a node. 100% transparent, so you can read everything. There's a relatively high level of anonymity. Performance is slow. Scaling is a massive challenge. There are monetary incentives for those running nodes, and because of the nature of the proof of work consensus algorithm, permissionless blockchains use an incredible amount of energy.
So of course, with Coreum, we know that performance is actually very fast. Scaling in parallel is highly achievable. It's a bonded proof of stake network, meaning that there's no miners. It's energy efficient as well.
The most obvious examples of permissionless blockchains today are, of course, the Bitcoin and the Ethereum blockchain. Very decentralized, very secure, very slow, and open to anyone with a web connection and a web-enabled device. So that was permissionless, and now permissioned blockchains, also known as private or centralized. Okay, so permissioned blockchains, they are closed ecosystems where all participants are well defined. Only pre-approved entities can run nodes. The degrees of decentralization and transparency are completely up to the company or companies running and configuring the blockchain. There's no anonymity. It does not require mining to validate transactions or execute smart contracts. It does not require a crypto economic incentive or tokens for those running nodes. And consensus mechanisms are computationally inexpensive, allowing permission blockchains to perform and scale much better than permissionless. Permissionless blockchains enjoy freedom in decentralization, and permissioned blockchains enjoy freedom in configurational flexibility.
Another piece that I enjoyed from this video is the question that they posed at the end.
Permissionless blockchains like Bitcoin and Ethereum incentivize people for running network nodes. There is no blockchain without nodes. So my question for you is, in a permissioned blockchain, what are the primary incentives for those running nodes?
And the answer they gave in their comments is, the answer to the question is, the primary incentive of running nodes on a permissioned blockchain is to lower down the cost, time, moreover to enhance the ease of sharing of information. So this reminds me of what David Schwartz says, which is the best incentive is no incentive when he talks about the XRP ledger. Specifically, he gave this presentation at the Stanford Blockchain Conference in 2020. Another piece to this permissioned versus permissionless and regulatory framework puzzle that I thought was relevant and interesting was Jae Kwon's recent post on this GitHub. And obviously this is concerning the Cosmos Hub. However, I also believe it's relevant because it's dealing with permission and permissionless. It says the challenge is to A, further refine and minimalize the aforementioned hub internal regulatory policy, and B, to define interzone permissionless regulatory framework. With these implemented, the hub can ensure the rights to property, protect the property in the case of theft, and allow zones to permissionally set their own policies. This is a critical architecture, constitutional/regulatory problem we should be discussing today. Until it is implemented, in my opinion, crypto will not be ready for the general population. He also goes on to say the problem is getting it wrong is significantly worse than not implementing it in the first place. And now to move on to drawing some parallels between Coreum and Corda. And my overall goal here is really just to inquire into the question of what is the relationship, if any, between Corda and Coreum. So over the past several days, I've been exploring the Corda platform documentation. And while I was reading, I figured I would take some screenshots and draw some parallels between the use cases, concepts, and technical info that I saw was similar between Corda and Coreum. So regarding use cases for Corda and Coreum, Corda trust technology powered by a financial grade DLT platform. R3's Corda is a scalable, permissioned peer-to-peer distributed ledger technology platform that enables building of applications that foster and deliver digital trust between parties in regulated markets. And for Coreum off of their website, Coreum provides developers and financial institutions with a complete essential infrastructure to build any DeFi applications. Another similarity I noticed is regarding Byzantine fault-tolerant consensus algorithms. On Corda's website, it says, improve scalability. In legacy blockchain systems, the network's ability to scale is limited to the network's ability to process each transaction and reach consensus on the state of the shared ledger. This means the network performance continues to degrade as more participants are added. Additionally, other systems limit the entire network to one consensus service, which acts as a major constraint. Separate notary pools also enable many algorithms to be run within a single network. This allows the parties to transact and to determine the best algorithm for their needs. Many transactions do not require the consensus of a full distrusting set of entities. Such transactions could gain in performance. The ability for Byzantine fault-tolerant algorithms to operate, however, is still anticipated to be the primary algorithm for uniqueness assurance and is fully supported by Corda. So in the Corda white paper, it mentions, in other situations where existing legal or trust relationships are less robust, slower but Byzantine fault-tolerant algorithms like BFT Smart may be preferable. Keeping in mind that Corda mentions it's also geared to work with non-BFT consensus algorithms as well. The Coreum white paper, it mentions the Coreum blockchain is distinct in many ways and incentivizes the network participants to conduct more transactions by providing bulk fee discounts. It is designed to solve real-world problems at scale by providing native token management systems such as decentralized exchange while being fully decentralized. In addition to the built on-chain solutions, Coreum uses WebAssembly to process smart contracts and utilizes Tendermint, Byzantine fault-tolerant consensus mechanism, and Cosmos SDK's proven bonded proof of stake. And in relation to scaling, one piece I found interesting was both Coreum and Corda talking about parallel processing. So on the Corda paper, it says a classic constraint on the scalability of blockchain systems is their nearly non-existent support for parallelism. The primary unit of parallelism in Corda is the flow. Many flows and thus ledger updates can be running simultaneously. Some node implementations can execute flows on multiple CPU cores concurrently, and the potential for sharing them across multi-server node also exists. Notary clusters can commit transactions in batches, and multiple independent notary clusters may be processing transactions in parallel. Transactions may also be verified in parallel. Because transactions are not globally ordered, but rather only ordered relative to each other via an input list, dependencies of a transaction don't depend on each other and may be verified simultaneously. And on the Coreum white paper, it says, in computer science, there is an irrevertible limit to how much you can scale a software by adding resources to it called vertical scaling. The solution to that problem is a parallelism formerly known as horizontal scaling. Coreum is incurring heavy research and development around the use of sidechains for exponential scalability and the production of more throughput when needed. A single chain can do up to 7,000 simple transactions per second. Consequently, by adding a single side chain, the throughput increases to 14,000. Of course, there are applications that cannot run on multiple side chains, for example, a DEX. For such use cases, a dedicated chain will run individually. The image below provides an overview of how sidechains will look like. So to me, I observed some similarities in the way that they talk about scaling related to parallelism and also for Coreum, the concept of horizontal scaling. And regarding interoperability on the Corda network enables interoperability, the exchange of data or assets via a secure, efficient internet layer in a way that isn't possible with separate isolated Corda networks. A common trust root surrounds all transactions, and a consistent set of network parameters ensures all participants may transact with each other. The network will support many subgroups of participants running particular core dApps, sometimes referred to as business networks, and these groups will often have coordinating party, the business network operator who manages the distribution of the app and rules, including membership for its use. There is a clear separation between areas of control for the network as a whole and for individual businesses' networks. Like the internet, Corda network intends to exist as a background utility. And regarding interoperability on Coreum, on their white paper, it says Coreum will enable communication to and from other blockchains. Users will be able to transfer tokens from external blockchains into Coreum and vice versa. For Cosmos SDK-based chains, Coreum will use IBC protocol, which is available as an open source component. IBC is an interoperability protocol designed for communicating arbitrary data between arbitrary state machines. It consists of two layers. A data transfer layer, which establishes communication channels by creating connectors and transferring data between chains, and then the application layer, which defines how messages should be encoded, decoded, and interpreted at the end of each communication channel. IBC protocol can be used for different use cases, including but not limited to transfers, interchain accounts, delegate calls between two chains, and Oracle data feeds. So both Coreum and Corda also mention serialization. It says CosmWasm fully embraces the actor model in which messages behave in a fire and forget manner. They do not wait for any promises to be fulfilled, removing the danger of race conditions. Actors send messages through a payment dispatcher as a communication mechanism. At the end here, it says ease of serialization. Messages can be serializable to many different formats so that they can be integrated with external systems. And in my study of Corda, specifically their conclave development system, it talks a lot about sterilization and desterilization of states or information. Object serialization frameworks must always consider security. Corda requires all types that may appear in serialized streams to mark themselves as safe for deserialization, and objects are only created via their constructors. So we see Corda exploring solutions for serialization and creating some mechanisms, and then we see an ease of serialization on Coreum. So we also see both Corda and Coreum talking about whitelisting. In Corda's white paper, it says state classes may request flows to begin at given times when a state is considered relevant by the vault and the implementing core dApp is installed and whitelisted by the administrator. The node may react to the passage of the time by starting new interactions with other nodes, people, or internal systems. Coreum white paper talks about whitelisting, saying whitelisting restricts the usage of a given token to a subset of authorized addresses. This feature enables some token creators to comply with regulations that require KYC or AML and can be extremely useful for institutional and governmental user types. At the time of token issuance, the user can specify whether holding, sending, or receiving and trading of the token is allowed by anyone or should restrict to users who are whitelisted. Coreum white paper also mentions whitelisting in their architecture. It says creating and minting tokens, fungible and non-fungible, on the Coreum blockchain is supported natively. The built-in functionalities allow token users to customize their tokenized assets with optional features such as wallet whitelisting, burning, and freezing when it comes to the heavily regulated financial markets like stocks and ETFs. And then finally, to kind of sum up my underlying question of, is there a relationship, and if so, what is it, between Corda and Coreum? I found this on their development documentation regarding a lending feature, and it says a solution. Now imagine a scenario where a single platform is created using Corda on which all the stakeholders could log in to see their personalized views about the loan. Corda is designed in such a way that an easy integration with siloed platforms belonging to each stakeholder is very well feasible. The single platform operates with the blockchain network that runs behind the scenes and constitutes all stakeholders as participants. Assets could be registered on the ledger of this network and traded as per the rules of the established contracts. The inherent capabilities of DLT would provide proof of ownership and asset tracking throughout the life cycle. So to me, after reading this, one of the things I think of is using a platform like Sologenic as an asset tokenization portal, as well as potentially an asset tokenization portal built on Coreum, as essentially a place where assets become digitized or tokenized onto the blockchain, and where they are then integrated potentially into the Corda DLT framework in a permissioned and regulatory environment. So maybe some of that was a little bit dry, but nonetheless, I feel that it is important to explore, ask questions, and for me personally, to begin to understand. And at the very least, I hope that highlighting some of these similarities can give us clues as to how enterprises are structuring digital trust and DLT frameworks for regulatory compliance, as well as the data standards that might be involved and how some of the balance of permission and permissionless technology is currently being crafted. So yeah, that's all I've got for this video, and I hope some of this info can at least be helpful in facilitating some deeper inquiry into these topics. If you are inspired, I'd love to hear what you think about all this. Leave me a comment, and thank you all for watching, and have a beautiful day. I will catch you in the next video.